So this video is going to kind of group a number of topics together to hope to get the main ideas and get rid of some of the nitty-gritty details, because we just don't have time for that this year. So we've talked about how one of the major tenets of evolution is the idea that organisms are related to one another. And some organisms are more closely related to each other than others. And so today we're going to look at some of the diversity that's created by the evolution, as well as how we can track those evolutionary relationships. So first off, when we talk about classification, which is what we're talking about, there's two major schemes. The first one is taxonomy. It's basically a way of describing grouping and naming organisms. You'll watch more about that in a video coming up, but basically it's shared characteristics. So way back in the day, mushrooms and trees would have been grouped together because they both are stationary in the ground. Now we know that they're shared characteristics, even just by characteristics, that they should be different. And so this is looking at characteristics. Phylogeny, which is what we'll focus on first, is more closely related to evolution because it's looking at evolutionary relationships and what organisms are most closely related because they evolved from a common ancestor more recently. So just to give you a brief example, taxonomy groups reptiles and birds into different groups. There's reptiles and there's birds. Reptiles have scales and lay leathery eggs and are cold-blooded. Birds fly, mostly have feathers, and are warm-blooded. But when we look at their relationships, we actually see that birds are very closely related to reptiles. In fact, they're descendants of dinosaurs. And so phylogeny would talk about birds as a type of reptile. When we try to figure out evolutionary relationships, we look at the different kinds of patterns of evolution. The first pattern makes figuring out evolutionary relationships a little bit tougher. It's called convergent evolution, and it's evolution that happens in unrelated species that are similar. So for example, if we look at the organisms in this picture, they all develop to a similar niche. They all live in the Arctic where it's covered in snow most of the time. And so being able to blend in that snow would make predators more easily able to hide. It would make prey more easily able to avoid detection by predators. And so all of the animals in the picture are white, despite sharing a common white ancestor. And so we have to be careful when we're looking for evolutionary relationships that we're taking into account that sometimes similarities don't come as a result of being related, but rather as a result of having a similar niche. But when we look at relatedness, most of the time we're looking for how did this one species diverge into different groups of species. So we talked already about how the whale came from a land animal that was kind of like a hippo. And so how did that happen? And that happened through a process known as divergent evolution. Divergent evolution is when populations accumulate differences over time until they're more and more different. A good example would be bears. Brown bears and polar bears have a close common ancestor, but as polar bears adapted to a more Arctic environment, they became more and more different, representing divergent evolution. What we're describing is speciation. Speciation is a process of new species coming to exist because the populations are isolated and they accumulate differences over time until the point where they're so different that they no longer mate. This process requires isolation because if individuals of different populations are mating, then any differences that come up because of mutations or natural selection get shared among the populations and they don't become more different, they get all mixed up. But if the two populations are isolated, speciation can occur. Now that we know how new species come to exist, let's talk about how we figure out those evolutionary relationships, or in other words, how we figure out phylogeny. So when we talk about the relatedness of individuals, what we talk about is a descent from a common ancestor. So in other words, they had a common ancestor, and as they speciated, as they became different species, they diverged, and so we group them by those divergent events. We can visually represent evolutionary relationships on diagrams such as this. This is called a cladogram. Wherever species branch off, we represent a common ancestor, and branching off represents divergent evolution. So let's back up. A cladogram is a diagram that shows the evolutionary lineage and speciation over time. Another way of looking at it is kind of like a family tree, only for species. And on a cladogram, you'll see that there are some characteristics here. So the characteristics that we see here and the characteristics that we see here, those characteristics are called derived characters. They are traits that are inherited from a common ancestor. All homologous structures are derived characters. Be careful. A structure known as analogous structure would be like the white fur on Arctic hares and polar bears. They happen because of niches, not because of ancestry, so you want to be really careful that we're not looking at any of those. When we interpret a cladogram, which unfortunately we won't have time to interpret it in much depth this year, but when we interpret a cladogram, we look at where they branch off from one another. Wherever a group branches off, the entire group that branches off is called a clade. It's an ancestor and all of its descendants. The branch points where they branch off is where that common ancestor is believed to have existed in the evolutionary lineage. So if we look at these cladograms, this is a clade in the green box. The common ancestor would be right here, and all of its descendants represented in the cladogram would come off of there. Notice that these other ones do not make up a clade because it wouldn't include all of the descendants. This evolutionary line and this evolutionary line, even though they're right next to each other, we'd have to trace it back all the way back down here to see where they attached. So it's not a full representation of all of the descendants of an organism. When we look at this cladogram, we can see, for example, that the human is most closely related to a whale compared to the other animals on this cladogram. So hopefully that makes sense. Whales and humans are both mammals compared to dinosaurs and tuna and whatnot, which are all more distantly related. And the reason I know that they're more closely related is that they branch off most closest to one another. A whale and a crocodile, we'd have to go all the way, trace it back all the way down here to get to a common ancestor that would include the Dimetrodon, the human, the crocodile, the T-Rex, and all of the other dinosaurs. Also note, where they fall on the cladogram doesn't really matter, so this cladogram would show the exact same information if the bird was here and the T-Rex was over here, or if the whale was here and the human were there. So what we're looking at is what branches off of what. Not whether they're on the left or the right of the diagram or how physically close they are to each other in the diagram, but rather where they branch off. In fact, this cladogram is showing the same evolutionary relationships as this cladogram. Notice both show birds and dinosaurs branching off together, indicating they share a common ancestor, and that both show the same branching patterns of reptiles and mammals and whatnot. I know I went through cladograms really, really quickly. All I want you to do is when you move on to more advanced classes in biology, you recognize these diagrams for showing evolutionary lineages. So that when you see something like this, you recognize that what it's showing is that the monkey is more closely related to a goat than it is to an owl. Because the monkey and the goat have a common ancestor right here, and to include the owl, we have to go back down to here. Okay, the rest of the PlayPosit is going to be videos made by people who are far better at doing it than I am. As always, make sure that if you have questions, you contact